Okay, now let's discuss something about the angular reforce and coefficient of limiting friction and two problems relating to sliding motion. Okay, first let us find out the relation between the angle of repose and coefficient of limiting friction. Okay, let's assume that this is the inclined plane. This is the inclined plane. This is the inclined plane. And a body of mass m is placed over it. The angle of inclination is theta. So weight of the mass is acting downwards, mg, and let us assume that this is x direction and normal direction is y direction. So to find out the y direction, I'm extending this line. To find out the component of the weight along the y direction, I'm extending this line and I'm also extending this line. So it makes an angle 90 degrees because it is completely horizontal. It is vertical, it completes 90 degrees, and this is x and this y. This makes an angle 90 degrees. This theta plus this angle x is equal to 90 degrees, and this is x, y, and this is y axis. So the angle between them is also 90 degrees. Therefore, this angle is equal to theta. Okay, the component of this weight force along the y direction, y prime direction, negative y prime direction is mg cos theta, and along the x direction is mg sin theta. Mg sin theta. But due to friction, the motion of the block is opposed. So frictional force is opposing the motion. Therefore, frictional force is acting in this direction. But at this angle theta equal to angle of repose, the body has not yet started its motion, but is about to start. Therefore, this is the limiting value of the friction, F. Okay, now we have mg cos theta divided by mg sin theta. Sorry, mg sin theta. Mg sin theta divided by mg cos theta is equal to tan theta is equal to F divided by normal direction end. Therefore, F by n is the coefficient of friction mu. Therefore, theta is equal to tan inverse of mu. This is the relation between the angle of repose and coefficient of limiting friction. Okay, this is the first case that I want to discuss. Okay, next case is I'm sliding down an object down an inclined plane, making an angle theta with the horizontal. The mass of the body is m, and another block of same mass from the same height is made to fall vertically downwards. The question is, which one of the two will hit the ground faster? This is frictionless. This surface has no friction. This is frictionless. Frictionless. Okay. So the initial velocities for the both cases are 0. Therefore, using the equation b square is equal to u square plus twice AS. Okay. This sliding motion has acceleration value a is equal to g sin theta. G sin theta, because along this component we have, as before, the component of the force is mg sin theta. Therefore, m is removing, the remaining terms are g sin theta. Therefore, acceleration is g sin theta. Okay. Now the initial velocity is going to 0. Therefore, the remaining term is twice g sin theta into, say, the tail length of the slope is called L. The tail length of the sliding of the inclining plane is equal to L. Now we have sin theta is equal to opposite. Let the height be height, opposite divided by hypotenuse. Therefore, L sin theta is equal to height. L sin theta is equal to height. Therefore, 2z height is equal to b square. Therefore, b is equal to root over 2z height. Final velocity is equal to 2z height. That means when this sliding mass hit the ground, its final velocity is 2z height. Again, for the mass drop vertically downwards, is to tell initial energy is potential energy is in the form of potential energy. It has no kinetic energy initially, and its total energy is equal to potential energy is equal to mgh. And when it hits the ground, no potential energy will be there. It will be all the potential energy is converted into kinetic energy, and it will possess the total energy mv1 square. Okay, so m cancelled. So final velocity is equal to root over twice gh. This is the expression for the final velocity. That means both masses will have the same final velocity when they hit the ground. Okay, now the question is, which one of the two masses will hit the ground faster? Okay, to find out, let's use the equation v is equal to u plus at. Okay, now initial velocity for both cases is 0. So u is removed, v is equal to at for both cases. So final velocity is also same, twice gh is same, is equal to acceleration for the second case is z sine theta, and acceleration for the mass sliding down is z sine theta, and is time taken is t1. Let's say, okay, implies time taken by the sliding block is equal to 2gh divided by z sine theta. 2gh divided by t1 is equal to root over 2gh divided by z sine theta. This is the expression for the time taken. Again, for the mass falling vertically downwards, the acceleration is z only. Okay, therefore, time taken by the body falling vertically is equal to t2 is equal to root over 2gh divided by z only. So now z sine theta is always less than g. Now the numerators are the same, the denominators are different. Here the denominator is smaller, here the denominator is larger. Therefore, t1 will be larger than t2. That means the body sliding down will take longer time to hit the ground as compared to the one made to fall vertically downwards. Okay, this is the first problem that I want to discuss. Next problem is when I slide down blocks of same masses along the inclined plane, okay, along the inclined plane having the angular inclination equal to theta, but the inclined plane is same. I mean, I'm made to fall, slide down. I made to fall a fall a block of mass m1 down an inclined plane first. Then it takes the time. It hits the ground with the final velocity equal to root over 2gh, where height is the height of the initial point. Height. Okay. Final velocity is equal to root over 2gh. Again, when I made to slide down another masses, m2, m1 is not equal to m2. Okay, it also hit the ground with the same velocity. Okay, root over 2gh. Okay, the question is, which one will slide down faster to hit the ground? Okay. Now, to find our time taken to hit the ground, let's use the equation v is equal to u plus at. Here, initial velocity for the both cases is 0. Yeah, final velocities are same. Acceleration involved is also same. Okay, therefore, time taken will be same. Time taken will not be dependent on the values of the masses, okay, that are sliding down the inclined plane. So, for the second case, when the two masses having different values of masses are made to slide down from the same height down an inclined plane, okay, both two masses will take the same time to hit the ground. This is the second problem that I just wanted to discuss for today. Thank you. After this, I want to discuss.